So we are going to break down 625 divided by 10,000. I would like to do that here. So we have 625 divided by 10,000. We're going to break it down. So my first instinct was to look at it and say, okay, I can divide both the denominator and numerator by 5. That was just my first instinct, okay? And if we divide 625 by 5, you will get 125. And if you divide this by 5, divide by 5, divide by 5, then you get 2,000 there, okay? I mean, this is for the sake of if you are doing this calculation and you suddenly find that you don't have a calculator, because with a calculator you can test all the way if you can divide both 10,000 and 625 by 625, which I think actually works, okay? But in the absence of having a calculator, you can break this thing down by yourself. And so the next breakdown also by 5, if you have 125 divided by 2,000, you can still break down by 5 again, you know, until you get to like having to see familiar numbers, you know. So this is going to be 25 and that is going to be 400, you know. Then you start getting to a place where the numbers become familiar to you, okay? And then if you continue with that process, I'm saying you don't have a calculator and you are trying to solve this problem. So if you divide again by 5, then you get to a place where it becomes maybe even more familiar to you to see that, now I have 5 over 80, you know. And when you get to 5 over 80, you get that feeling of, okay, I know that 16 times 5 is 80, which means that eventually this calculation lands you to what? To 1 over 16, okay? So 1 over 16. So in the beginning, if you have a calculator and you have divided 625 by 625, you will get 1, and 10,000 by 625, you will get 16. So it means that 625 divided by 10,000 could be simplified by dividing by 625, okay, which will be 1 over 16. So in continuing with this calculation, we can now say that we now know that 8 raised to power n is equal to 1 over 16. I think that much we can now say that 8 raised to power n is equal to 1 over 16, because we know that 625 divided by 10,000 is equal to 1 over 16. Now we have a way to move ahead using indices, and we're going to use 2 as the base, okay? So we know now that 2 raised to power 3 multiplied by n is equal to 2 raised to power minus 4, because 1 over 16, I mean 16 is the same thing as 2 raised to power 4, okay? And 1 over 16 is it's in a reciprocal form. So to change it back to non-reciprocal form, we have to use 2 raised to the power minus 4. So the knowledge of indices is very important to be able to succeed with this kind of calculation. So now that the bases are the same, we have 2 on the left, 2 on the right, then we know that the powers 3 raised to the power n is equal to minus 4. So we can divide both sides by 3. Therefore, n will be equals to minus 4 over 3, or minus 1 whole number 1 over 3. So that is how to evaluate this calculation with log of 8, 0.0625. We start by assuming that we let n be equals to that decimal, but written in fraction form, it's 625 divided by 10,000. Simplifying that, we get 1 over 16. So these are some examples of how we can evaluate logarithms. We have seen logarithms with whole numbers, we have seen those with a decimal, fraction, and now even a decimal with 0.0625. We can take 2 more examples from this kind of calculation. One more with decimal and one more with a whole number. So the next log that we're going to evaluate is log base 1.2 and then 1.728. When you see this kind of calculation, the first thing you should try to do is try to establish if there's a connection between the base 1.2 and then the number that you're trying to calculate, 1.728. And because I've looked at these questions before now, I've been able to establish the connection between 1.2 and 1.728. And the connection I established was that 1.2 times 1.2 times 1.2 is equal to 1.728. So that connection I have established before coming on this live presentation, which means that I have established that 1.728 is equal to 1.2 raised to the power 3. So we're going to be able to calculate this problem or evaluate this problem because I've done a previous investigation on the connection between them. Okay. So we make an assumption again. We assume that n is equal to log 1.2 and then 1.728, which is a decimal number, 1.728. So we can now state that 1.2 raised to the power n is equal to 1.728. And I have previously established that 1.728 is equal to 1.2 raised to the power 3. So we can write now that 1.2 raised to the power n is equal to 1.2 raised to the power 3. Now that the base are the same, we can just make a conclusion that n is equal to 3, and we leave it there. We take the next question immediately, and that one is log 0.225. So log 0.2, and then we have 25. We are going to continue with our assumption. So we let n, this time around, we say let n be equals to log 0.2, then 25. So we know now that 0.2 raised to the power n is equal to 25. Okay? Earlier on today, we have worked with 0.2. Okay, it's gone now. We have worked with 0.2 in the sense that first we know that 0.2 is the same thing as 2 over 10, but for the purpose of being able to write it in index form, we have gone all the way to write it as 1 over 5, okay, which is a number in reciprocal form, and that is the same thing as writing 5 raised to power minus 1. Okay, so indices, the knowledge of indices is vital to be able to do these evaluations. So here we can write 1 over 5. We can start with 1 over 5 raised to power n is equal to 5 raised to power 2, and then we can say 5 raised to power 5 raised to power minus 1 n okay, 5 raised to power minus 1 n is equal to 5 raised to power 2. So we can write it like that, like and 5 raised to power minus 1 n is something as 5 raised to power minus n, okay? So we can actually continue with this calculation there and write 5 raised to power minus n is equal to 5 raised to power 2, which means that if we say minus n is equal to 2, I mean, since the bases are the same, then we equate the powers. Therefore, n is equal to minus 2. We can make that conclusion, okay? So 5 raised to power minus 1 multiplied by n, that's the same thing as 5 raised to power minus n. When the bases are the same, we equate the powers. So minus n is equal to 2. We multiply minus n with a negative sign to become n. If we multiply 2 with a negative sign, it becomes minus 2. So these are the evaluations that I have in mind tonight, but I'm going to solve 3 more problems. I shared these problems on my TikTok channel earlier on. So I have 3 more questions that I'm going to solve tonight. So it will go according to the plan for today. So these questions are based on theory of logarithm, which I talked about last week. The problem is that not everyone is present at all my lessons, but for me it's impossible to repeat myself all the time, unfortunately. So I'm going to apply the theory of logarithm. The theory of logarithm you can also call like the laws of logarithms, okay, and they are based also on the laws of indices. So the first one, where you have log 3 plus log 4, what you're going to do is that we need to apply the first law, which is going to be some kind of a multiplication. So so log 3 plus log 4, and I'm saying plus, I mean plus, okay? So some Swedish sometimes straight out of my mouth. So log 3 plus log 4 is the same thing as log of 3 times 4, okay, times 4 times 4. So that means we can write, we can express this logarithm as a single number, which will be log 12, okay? So log 3 plus log 4, according to the law of logarithms, or the theory of logarithms, we can now multiply 3 and 4 inside a bracket. So log 3 plus log 4 is another way to express log 12 by applying the law of logarithm. The second one is also based on one of the laws, one of the theories. We have 3 over 4 log 16. Before we can have 3 over 4 multiplied by log 16, we have previously had this like log 16 raised to power 3 over 4. And it means that there are 2 operations that we need to carry out. We have to carry out 2 operations on log 16, okay? The first one is like finding the 4th root of 16, and the second one is writing this raised to power 3. So this is the same thing as a log of 1 over 4 times 3, okay? Or we can say the same thing as log of 1 over 4 raised to power 1 over 4. You can transform it to 4th root of 16. And then the multiply by 3 will be something like this, raised to power 3. So there are 2 operations we need to carry out on log of 16. The fourth root of 16, okay, is 2, okay, because 2 times 2 times 2 times 2 is 16. So if you're calculating the 4th root of 16, your answer is 2, okay? So the 4th root of 16, you get 2, and then 2 raised to power 3, you will get 8. So the answer to that question is log of 8, which means in expressing the logarithm 3 over 4 multiplied by log 16 as a single number, we land on log 8, okay? Which is the same thing here. If we do 4th root of 16, we will get 2, and 2 raised to power 3 is 8. So it's important to be able to use these fractions when they occur as powers, to know which one is the root and which one is the raised to power, whatever it's going to be. So if you have 3 over 4, you find the 4th root and you do raised to power 3. Okay, the 4th root of 16 is 2, and 2 raised to power 3 is 8. So expressing that number as a single number, expressing 3 over 4 log 16 as a single number, the answer is log 8. Quickly, we take the last question and wrap it up for today. The last question, for those that are familiar with examinations in West Africa, you can see WAEC, WAEC. It means West African Examination Council. So it's like a common exams for West African schools. So it's like a past question. And not using tables, you are expected now to evaluate 3 log 2 plus log 20 minus log 1.6. To be able to solve this problem, like I said earlier on, you have to apply the theory of logarithm. So first of all, you have to learn the theory, and then you have to be able to apply it. So these things come in step by step. My lessons today are a guide for you to go back and check out this theory of logarithm. If you're in your final year secondary school in Nigeria or West African countries, and if you need more help, you can always write to me privately. I can help out. Tomorrow's lesson is going to be on percentage, and it's going to be conducted in Swedish language. So that is what I'm doing now on my TikTok channels. I'm speaking both English and Swedish. 3 log 2 plus log 20. I would have to apply the theory of logarithm. First of all, I can rewrite this part. I can rewrite that. I can rewrite it as log 2 raised to power 3. I can do that. So let's rewrite the first part. Then log 20 minus log 1.6. So the only thing we have done now is to rewrite the first part. 3 multiplied by log of 2 comes from the fact that we have log 2 raised to power 3. And 2 raised to power 3 is 8. So that means this calculation is actually log 8 plus log 20 minus log 1.6. And according to the theory, we can multiply these two and then we divide by that. So this means we have log of 8 times 20, which we can divide by 1.6. Okay, and 8 times 20 is the same thing as 160. So this is the same thing as log of 160 divided by 1.6. So that would be log of, when you see 160 and 16, okay, what should easily come to your mind is that, okay, if you multiply the denominator, sorry, if you multiply the numerator and the denominator, if you multiply them by 10, you will get 1,600 divided by 16. So this is easily going to give you log 100. And log of 100 can be simplified further. The answer is 2. The answer to this question is 2. So we take it one more time. We apply the law of, or the theory of logarithm, which says that if we have to, first we deal with this, we change this to 2 raised to the power 3, okay? And that gives us 8. So we have log 8 plus log 20 minus log 1.6. When we have plus in between, we apply the theory of logarithm, which says we can multiply 8 and 20. And then because there is subtraction there, we can divide 1.6 with 1.6. So 8 times 20 is 160. 160 divided by 1.6 is 100. Log of 100 is the same thing as 2. Don't forget to follow this page and come back tomorrow all week for more lessons. Tomorrow, like I said, I'll be taking my lesson in Swedish language.